A second approach is of metabolomics, how investigators have used our technologies, and more of a multiomics approach to use metabolomics to functionally map variants of unknown significance in genetic studies. And I think this is arguably one of the most innovative applications of our technology, because the question is, or the idea is, that you can take your GWAS in a large population study. And when I say large population, I'm talking like genetic numbers. Like these are thousands of subjects, thousands of patients or subjects in the cohort. And the question is, can you identify a variant that results in a change or associates with a change in a biochemical step? And in that way, you're able to map the function of what that variant is doing in that individual. And if you'd asked me before the study was done if that would actually work, given some of the power of the study and the kind of powers that you need to see for allele frequencies for some of these, I would have said it would never have worked. It's a good thing that I wasn't listened to or I wasn't questioned, because it actually worked extremely well, and it's a very powerful approach now and well adopted. And the initial approach was discovered or vetted by Carsten Surrey at Weill Cornell. And in this specific example that I show here on the left, SLCO1B1 is a solute transporter where variants were known to be associated with increased mortality and increased risk of heart failure. But the mechanism was completely unknown. And it was a study that he did where he looked at about 6,000 subjects across two different cohorts, Twins UK, which Brian mentioned earlier, and then a Cora cohort, which is a German-specific cohort that acted as kind of a discovery and validation arm in the study. And he identified variants in the solute transporter that associated with levels of a single nucleotide or single metabolite called hexadecane dioate, a dicarboxylic fatty acid that's typically involved in peroxisomal function. And that was a massive surprise, because solute transporter is not thought to be relevant for this class of molecules, but clearly there's an association where this variant was associated with altered circulating levels in the plasma of this metabolite for individuals who had variants in that gene. And then validation came from another cohort called the ERIC cohort, led by Eric Boerwinkle at University of Texas Southwestern, where in that cohort, they identified a dosing effect of loss of function of alleles at a specific locus or specific allele in that same transporter, where you see that the putative loss of function homozygous allele results in a profound increase in circulating levels of the same metabolite in a distinct cohort. And because this is known to be associated with heart failure, the hypothesis is that this could be directly related, this metabolite could be directly related to the function of this variant that's known to be associated with increased risk of heart failure. So Christina Meni at King's College in London tested that hypothesis, and she actually dosed rats with this specific molecule. So starting at day 9 after an acclimation period, relative to placebo or vehicle treatment group, animals dosed with hexadecane dioate showed a marked increase in systolic blood pressure, showing a specific and causal effect of this, that this could be the actual mechanism by which SLCO1B1 is mediating increased mortality and increased risk of heart failure. And that's because, according to World Health Organization statistics, as of 2020, there are 1.5 billion people in the world with hypertension, and 1 billion of them, 2/3, almost 1 billion people, are not receiving their targeted therapeutic therapy, and there's a lockstep association between increased blood pressure and increased mortality. So this study shows that perhaps there could be another way for new modalities and new treatments for disease, which are desperately treated, because it remains a grave global concern.